definitely seems like it's starting to get darker and darker, isn't it? Like, start of the semester it was like super bright and early, now it's just like, it's just like dark blue, and now it's like, okay, welcome, yep, we're slowly entering fall, even if we are technically in it. Like, last week was like, whatever, it's fine, but now it's just like, this week is like, well, like, here's your wake-up call, ladies and gentlemen. That's what it felt like. Okay, well, let's go ahead and get started since it is now 8:30. So, just any quick questions on anything, any homework questions that you would like to address? Okay, well, then just a couple of quick announcements. So, like I've been saying last week, so quiz 7 is going to be opens up on Wednesday, and you have until Thursday to complete it, covering lessons 19 and 20. Quiz 8 is going to be next Monday, and it closes on the following Tuesday, covering lessons 21 and 22. So basically, today's lesson, and then next time's lesson. All right. So without further ado, let's go ahead and look at lesson 21, the graphical interpretation of derivatives. Okay. So the goal of this lesson is basically to take all the things we know so far up until this point and then figure out, okay, how can we find these properties given instead the graph of the derivative of a function? So the thing is, we've already seen all this stuff before, but now we have to view it in a different way now because in this case, now we're given different data. So in this case, let's go ahead and take a look at all these definitions, recall them and see, how can we view them in the light of what we're going to be doing today. So a critical point / number is an x value, or x values, where f prime of x equals 0, or f prime of x does not exist. Okay? So the nice thing is that in this homework, we don't really have to deal with this. So not on this homework. So we're not going to really worry too much about the does not exist part. So we're mainly going to focus on when f prime of x equals 0. So the thing is that if we're given the graph of f prime of x this time around, that must mean that in the context of a graph, that must mean that when it equals 0, it has to touch the x-axis, right? So as a result of this, so graph of f prime of x touches x-axis. Okay? So that's the idea of a critical point / number. And what I'm also going to do is I'm also going to put here on the left, I'm going to put here an x value. And you'll see why in a second. Okay? So now moving on to the next thing, we have this idea of an increasing interval. So if you recall, that's when we say, all right, well, that's when f prime of x is greater than 0. So in the context of a graph of f prime, that must mean, all right, well, we have to focus on when the graph of f prime is positive, or in the context of a graph, when it's above the x-axis. So graph of f prime of x above x-axis. Okay? And in this case, we have increasing and decreasing. This is going to correspond to an interval. Okay? Okay, so now that we have that, let's take a look at decreasing. So now in this case, f prime of x is now going to be negative. So now that we have this, in light of what we established here, increasing meant that the graph was going to be of f prime of x would be above the x-axis, So what should that tell you about decreasing?
Okay, it's going to be below that x-axis.
Exactly. So the graph of f prime of x is below the x-axis. Okay. And like increasing, this is also going to be an interval. Okay. We also have this idea of a relative maximum where it says, all right, so f of x goes from increasing to decreasing. Okay, so now let's take a look at what this means. So like we've already seen before, relative maximums or relative maxima correspond to an x value. Okay, so in this case, if we f of x goes from increasing to decreasing. So what that means is that, all right, so if we take a look at the graph of f prime of x, well, if f is increasing, that must mean it's going from increasing to decreasing. That must mean it's f prime has to be going from positive to negative. So in light of that, that should probably say, all right, that must mean that its graph has to go from above the x-axis to below the x-axis. Okay? So graph of f prime crosses x-axis from positive to negative. Okay? And then similarly, relative minimum says, all right, f of x goes from decreasing to increasing. So in light of that, that should probably tell you that the graph of f prime of x. So if we take a similar cue as to what we just established up here with the relative maximum, what do you think will happen with the relative minimum? So the graph of f of x would do what?
Cross the x-axis from negative to positive.
Exactly. So it crosses x-axis from negative to positive. Okay. And this is also again going to be an x value. Okay. So now let's take a look at the concavity and inflection point concepts again. So concavity, if concave up, says, all right, f double prime of x has to be positive. So if you recall from lesson, I think it was lesson 18, I believe. So if you recall from, no, not lesson 18, I think it was lesson 19, something like that. That's when we formally established concavity. Yeah, lesson 19. Okay. So if you remember from lesson 19, if f double prime of x is positive, what should that tell you about what f prime of x is doing? So if the second derivative is positive, what should that tell you about the first derivative? You guys remember? Okay. So I'll just go ahead and say that. So I'll say basically, if you recall, so it's where f prime of x increases. Okay? Because if you have that if a function increases, that directly corresponds to its derivative being positive. Okay? And similarly, if you have concave down, well, that must mean you have its second derivative is negative. So as a result, f prime of x would have to be doing what there? Decreasing. Good. Okay? And with the concavity up and down, these are both going to be intervals. Let's see. Interval and interval. And inflection points, which correspond to x values. So this is where the second derivative changes sign. So in the context of f prime of x, that's where f prime of x goes from increasing to decreasing, or vice versa. Okay. So one thing you may have noticed with all this is that says, all right, we're only given the graph of f prime of x, and we're not actually given the graph of, we're not given any other data of f of x beyond that. So in this case, all these correspond to x values slash integrals. Or sorry, intervals, sorry. Okay? We need the equation slash graph of f of x to find the y values. So in today's lesson, we only care about the x values slash intervals. We don't care about the y values because there's no way we can extract it from just f prime. Unless we have other information about f of x. Okay? So any questions on that before we move on to our first example? Okay. So, give you guys a second to finish that up. Alright, so let's take a look at example 1. So basically all today's examples are going to be, we have a graph of the derivative of f of x below. We need to find the following for f of x. Okay? So the first thing we have to take a look at is the critical number. So basically let's go ahead and go down the list and see what kind of things we need here. So first off, the critical numbers says, alright, in this case we only care about when f prime equals 0, or when it touches the x-axis. So taking a look at this graph, well, that should pretty quickly tell you that, well, the critical number in this case should be where? Let's give it a second. So where would our critical number be? So if we basically we have to figure out where this graph touches the x-axis. So in letting this be the x-axis, well, that should pretty quickly tell you that the critical number is where? 0, right? So in this case, that's the only time where it touches the x-axis. So that's that. Okay. Now let's move on to the increasing and decreasing intervals. So that says, all right. But in the context of f prime, that says, all right, increasing means we have to be above the x-axis, and decreasing means we got to be below it. So taking a look at our graph, our increasing interval would have to be what? So if we're above the x-axis, that must mean that our increasing interval slash intervals would have to be what? Yeah?
0 to infinity.
Yep. 0 to infinity, and consequently the decreasing interval would be
Negative infinity to 0.
Yep, negative infinity to 0, right? Okay. So that takes care of that. So now let's move on to the relative extreme. Okay, so with this we say, all right, so with the relative maximum, the graph of f prime has to cross the x-axis from positive to negative, but with the relative minimum, it has to cross the x-axis from negative to positive. So in light of that, that says, all right, what would that tell you about the number of relative maxima? So if it has to cross the x-axis from negative to positive, or no, positive to negative for the maximum, and minimum has to cross the x-axis from negative to positive. So let's start with the maximum. Is there any point where the graph of f prime crosses from positive to negative? No, right? So nothing here. And then relative minima says, well, okay, well, we would have to be, based off our definition, have to be what? Have to be x equals which one? 0, right? Okay, so that's that, but one thing you might notice is that another way to see this, what's going on, is that you can also use a number line that we've been doing up until this point, right? So if we draw a number line for f prime, what we notice is that, all right, well, we have a critical number at 0, so let's go ahead and use that. But then what you also notice is that, well, we already know f prime to the left of 0, well, that's negative because of this part here. So negative, so decreasing. And then because we're above the x-axis, if we're greater than 0, that must mean that f prime is going to be positive, so f is increasing. So you can use a first derivative test / this number line to tell you, okay, there has to be a relative minima at x equals 0. So that's another way to see that, just to be a bit more consistent with what we've been doing. Okay. So now we have that. So now let's move on to the concavity intervals. So for the concave up, well, that says, if you recall, that's where f prime of x is increasing. So assuming this similar behavior holds for all real numbers, that must tell you that the concave up interval / intervals would have to be what? Actually, let's give someone else a chance. So take a look at our function here. Where's f prime of x increasing? Go ahead.
Is it negative infinity to positive infinity?
Exactly. So negative infinity to positive infinity. Because like we said, because the thing is that even though we do have a critical number here, because this function is increasing everywhere except one particular point, so even though we do technically have negative infinity to 0 and 0 to infinity, the thing is that we have two back-to-back intervals with the same property, so you basically have to merge them together to get the desired concave interval, right? And then the nice thing is that as a result, well, that should pretty quickly tell you that there can't be any concave down intervals because concave up encompasses the entire real line, so concave down is gone. And since the concavity doesn't change, well, that should tell you the number of inflection points is 0, right? So no inflection points. Okay. So any questions on any of that? All right, cool. All right, so now let's move on to example 2. So basically, now we have a parabola that sort of dips below the x-axis a bit, and this will be our f prime of x now. Okay. So the nice thing is, assuming each of these tick marks have distance 1, so in this case this would be 1, this would be 2, 3, 4, and 5. Let's go ahead and use that to figure out the 8 properties that we've established. Okay? So in this case, let's take a look at the first one. So critical number, that says, all right, well, where's f prime of x equal to 0?
-1.
Yep, x equals -1, and x equals +1. Okay, so that one's pretty relatively straightforward because, well, the graph of f prime crosses the x-axis at negative and positive 1. So nothing too crazy with that. But now what about the increasing and decreasing intervals? So what would they be here?
Like the increasing would be from negative to 1 and from 1 to infinity.
Close. I think you, because remember it's negative infinity to, remember we have to be above the x-axis for,
Negative 1.
there we go.
Yeah.
Negative 1 and then 1 to infinity. Okay? And then so consequently the decreasing interval would be, yep, negative 1 to positive 1. Good. Okay? So that takes care of that. So in this case, now for the relative extrema, now let's go ahead and use our number line to help us see a bit more clearly what's going on. So, in this case we have two critical points, negative and positive 1. So in this case we say, alright, well as we've already established, the increasing intervals where f prime is positive has to be negative infinity to negative 1 and 1 to infinity. So we have positive here and positive here. So increasing and increasing. And our decreasing intervals, where f prime is negative, is from negative to positive 1. So f prime is negative slash f is decreasing. So using this number line, we can pretty quickly see that the relative maxima and the relative minima are each going to be what? So starting with the relative maxima, we have what? Yep, negative 1, because we're going from increasing to decreasing, and then relative minima, positive 1. Good. Going from negative to decreasing to increasing. Now for concave up intervals, let's see. Now in this case, we have to focus on when f prime of x is increasing. So when is this graph increasing? So I'm just trying to see if I can pick, I'm trying to have more people answer so we can. So when is our graph increasing? Remember, if a graph is increasing, that means that if x is going to the right, x is increasing along the x-axis in the x direction, the graph should be going up as well. So, when do we have concave up?
Zero to infinity.
0 to infinity. And then concave down consequently should be what?
Negative infinity to 0.
Yep, negative infinity to 0. And then as a result, the inflection point / point should be what? Go ahead.
0.
Just 0, right? Because that's the only point where the concavity changes, so that's what we have for that. Okay? So, any questions on example 2? Okay. Alright, so with this one, now we have example 3 for the derivative of f of x. In this case, we only have to find the critical numbers, the increasing, decreasing intervals, and just the relative extrema. No concavity here. Because here it's going to be a bit harder to determine the concavity intervals. So here, just focus on the first 5 things we've talked about. Alright? So, in this case, now let's take a look at the critical numbers. So, based off of our graph, it looks like we have 3 points where it touches the x-axis. So, in this case, you would have, so in this case, for those 3 numbers, those would be what? So, just taking a look at them, we have -3, 0, and 3, right? Okay. So, as a result of that, well, what would the increasing intervals be? because in this case, that's where those are the intervals that correspond to when the function of, well, f prime of x is above the x-axis. And then someone else, what would be the decreasing intervals?
Negative infinity to negative 3 and 0 to 3.
Yeah, 0 to 3. So negative infinity to negative 3, and then 0 to 3. Okay. So then for the relative extrema, let's go ahead and draw our good old number line. So if you can use a number line, or you can use the definition that we talked about at the start of the lesson. So we have negative 3, 0, and 3. So if we use this number line and fill it in as necessary, what should we get as our relative maxima and relative minima? Go ahead.
Maximum at 0.
Okay.
And then relative minimum at negative 3 and 3.
Yep, negative 3 and positive 3. Good. Okay. Because what you notice is that, well, for the increasing intervals, those correspond to negative 3 to 0, and then 3 to infinity. So we have positive here, increasing, increasing. And the decreasing intervals are going to be from negative infinity to negative 3, and then 0 to 3. So we have decreasing here. Okay, so the first derivative will be negative. Okay. Okay. So that takes care of example 3. So any questions on that? Alright, well, tell you what. I think you guys are starting to get the hang of this, so why don't we do this? So why don't you guys, I'll give you guys a few minutes to try out example 4 on your own, and then we'll reconvene in about 5 or so minutes. So I'll show you guys some example 4 so you guys know what I'm talking about. So, give you guys about up till 9 o'clock or so, and then we'll reconvene. Give you guys about 1 more minute. Okay. Okay. So let's go ahead and reconvene. So for the first problem, let's go ahead and go down the line. So let's see. What did you get for the first one? Yeah. So critical numbers, what'd you get?
X equals -2, 0, and 2.
Where are you getting 0 from though?
Well, just X equals -2 and 2.
Yeah, because remember, for the critical numbers, we only care about when it touches the x-axis. So, okay, and then let's see for the increasing intervals. Let's see. For the increasing intervals, let's see. Let's go and pick on you.
Negative infinity.
Yep, negative infinity to positive infinity, and then consequently the decreasing intervals is no. Good. Okay, and then let's see for the relative. If we draw the corresponding number line. Well, actually, let's go into this. So, what did you get for the relative maxima?
I put none.
None. Good. And why aren't there any?
Since there isn't a change from above and below the x-axis.
Right. So that would tell you that one. So that means the relative. So consequently, the relative minima would be what?
None.
Exactly. So that part's not too bad. But now here's where things get a bit more interesting. So for the concave up and concave down intervals, we actually do have to be a bit careful with how things change a bit. So for the concave up intervals,
I said negative infinity.
you have to be a bit careful. So remember, concave up corresponds to when f prime of x is increasing, right?
Yeah.
So
So would it be negative infinity to 0? And then
not quite. So let's focus on when f prime of x goes from increasing to decreasing, right? So in this case, let's sort of take a look at sort of the critical numbers of f prime of x. So I think in this case, it might be better to start with the inflection points in this case. So if we take a look at f prime of x, where does the graph change from increasing to decreasing?
oh, negative
Okay, x equals -2 to start off, and then x equals
2.
okay. That's the last one. But then what's the third one?
Oh,
0, right? Okay. So now taking a look at that, we say, all right, now let's break up the graph into based off of those inflection points. So now that we have the inflection points, which basically correspond to the critical points of f prime, let's go ahead and use them to find the concave up and concave down intervals. So for the concave up, we say, all right, well, we have to focus on when f prime of x increases. So in lieu of that, that would mean that your concave up intervals would be
from -2 to 0, and then from 2 to infinity.
okay, 2 to infinity. And then last but not least, the concave down intervals. Let's see. What would the concave down intervals be? So remember, concave down corresponds to when f prime decreases. So when is f prime of x going When is f prime of x going down? As x goes along with the root. Yep, negative infinity to negative 2. So that's one of them. And then when is it decreasing again?
0,
Yep. Sorry, it should be negative 2. And then 0 to 2. Good. Okay. And that's example 4. So, any questions on that part?
For the increasing part, like, I broke it where it touched the x-axis. Is that wrong?
So, well, in not technically, but in the context of the homework, it will want you to put them together.
Okay.
So, technically, yeah. So did you have like negative infinity to negative 2, and then negative 2 to positive? Okay.
Yeah. I figured you might have put it like that because that's how like the homework wanted it, but I was just curious. I mean, I guess they're probably both like, in the grand scheme of things, like acceptable, but that's just how the homework wants it.
Yeah, essentially, because like even though like technically speaking, it's strictly above the x-axis on these intervals, but again, they're all essentially like so taking a look at this interval, for instance, here's two intervals that have the same property back to back, so mesh them together, and then so ultimately you have that negative infinity to 2. Union 2 to infinity. But then again, you have two more intervals that have the same property, so mesh them together to get the whole real one. Okay? Okay, so that's example 4. So any questions on that? Alright. Yep.
So is our whole homework just going to be graphs and then these questions?
Basically. Yep. Just here's a graph, find these properties. Okay. And then let's do one more. And basically just find the same 8 properties, except now we're going to a slightly different graph. So since the numbers are a bit hard to see, I'll go ahead and zoom in. But basically you'll find the same 8 properties that we've been finding up until this point. So let me just zoom out on the graph so you guys can see what's happening. So basically here we have 3, and here we have 14. So that's essentially all you really need to know. But so other than that, it's just do the same thing that we've been doing. So you guys a few minutes to tackle that, and then we'll reconvene. Oh yeah, also missing one point. This should also be 9. Okay, so this will also be 9. That's the other thing we need. Give you guys about one more minute. Okay, so let's go ahead and reconvene. So first off, let's take a look at the critical numbers. So raise your hand if you have the critical numbers.
3 and 14.
Yep, x equals 3 and x equals 14. Okay, good. So that one's not too crazy. Then let's see, what would the increasing and decreasing intervals be?
Negative infinity 3 and then 14 to infinity.
Yep, 14 to infinity. So that would be increasing, and then consequently decreasing would be what?
3 to 14.
Yep, 3 to 14. Okay. So that takes care of that. So now now let's take a look at the relative extrema. So let's see. What would the relative maxima be?
3.
Yep, x equals 3. And the relative minima would be
14.
14. Good. And one way you can see that is that if you use our good old line charts, number line, what you notice is that we have critical points at 3 and 14. We have increasing intervals at negative infinity to 3 and then 14 to infinity. And then decreasing from 3 to 14. So you can use this number line to help you classify the relative extrema. Okay. And then let's see. For the concave up intervals, what would that be? So let's take a look at that. So what would the concave up intervals be? Or interval or intervals? Well, yeah. So concave up interval or intervals. What would that be? So where is our function here increasing?
From 14 to infinity.
Well, this function. Well, remember, when is f prime increasing? I guess you should say. So this is f prime of x, right? So when is a function increasing?
From 9 to infinity.
9 to infinity. Good. Okay, and then as a result, let's see. What would the concave down interval be? Yep, and then the inflection point. Yep, good. Negative infinity to 9, and so the inflection point is just 9. Right. Okay, and that is example 5. And well, that's it for what I had for today. So, any questions on any of that? All right, well, looks like you guys get extra 5 minutes of freedom today, so I'll let you guys go ahead and enjoy that, and I will see you guys on Wednesday. Yes. Also, I probably should mention this, Zoom office hours tonight if you guys want to take advantage of it. Other than that, yeah. Otherwise, see you on Wednesday.
See you.
See you.